Our speaker today is a senior executive at IBM and has been a high-level partner, and IBM's been a high-level partner with UMBC for a number of years. They've shared a lot of our common core values, in other words, valuing broadening basic science, math, engineering, and also making sure that we have that group of K through 12 students that are ready to be active participants in helping us move forward in STEM fields. So it's also been a great partnership that we've had. IBM in the last few years has collaborated with us in a number of ways. For example, in terms of helping us establish what we call our multi-core computational center, which is actually doing well, and we're making plans on how we can grow that. I know also a number of your firms are actually participating in that as a center activity, and we want to see that move forward in terms of both providing opportunities to learn about this technology, but also to advance the frontiers of knowledge and learning. UMBC has been a supporter of our faculty, both in the Department of Information Systems and in computer science through IBM Faculty Awards. We're pleased to have that kind of support and recognition of the quality of our faculty. And then the other thing that I mentioned, my goal is our graduates end up being embedded in all of your companies, but also we want to make sure that companies like IBM hire our graduates. So this is a thing that we want to do. This is how we build our reputation, and we think we benefit the competitiveness of business and industry in this area. And so we're really grateful for all of the support of all those who support this forum, but also our connection with IBM. We still, as a university, UMBC continues to be recognized as a leader in excellence. For example, UMBC this past year was one of the best valued colleges and universities, and also has been recognized for its diversity of its student body. We're pleased at that because we know that that represents the highly competitive workforce that we're going to have for the future. We're the second highest producer of graduates in STEM fields in the state of Maryland. First is, of course, the Naval Academy, but we have about 40 to 45% of our graduates graduating in STEM fields from UMBC, so that's important for our economic and competitive future. And we seek to build these kind of business, industry, university connections. It's important for us. And we hope that we can look forward to continued cooperation, continued hosting these kinds of forums. We hope they're of value to you, and we find them valuable to us at UMBC. I'm pleased to introduce this morning's speaker, Rich Lechner of IBM, and he's going to be talking to us today about sustainability and the role of information technology. Rich is Vice President of Energy and Environment at IBM. I had a chance to talk with him last night. He assumed this role actually last fall after he had been engaged in these kind of activities within the corporation for a number of years. It's an important new direction or formally recognized direction that the company is going, but I think it's important for all of us in the academic community as well as the business and industry and government community to think about, plan, and determine how we're going to move forward on this. So Rich leads IBM's efforts in helping clients address the issues and opportunities around energy, the environment, and sustainability, and helps define that strategy in managing a broad portfolio of capabilities that IBM technology, innovation, and insight can bring to their clients around the world. So I'm actually delighted to welcome Rich as he shares his insight and perspectives on smarter planet, sustainability, and the role of IT. Rich?
Thank you all. Good morning, and thanks for the opportunity to be here. I couldn't be happier to spend some time with you all. I'd like this to be as informal and interactive as possible, so I'll try to go fairly quickly so we have time for a Q&A at the end. But I'd encourage you, if you want to ask a question or rebut something I say, feel free to raise your hand as we're going along here. The scope really today is about the role that technology can play, whoa, that wasn't me, in addressing these profound issues that we're facing. It's about remediation. I'm not going to talk at all about adaptation, but that's another very important topic and one that we have a point of view on and perhaps fodder for another meeting. And I mention that simply because IBM sponsored with the Carbon Disclosure Project a report that came out just this week on the whole issue of adaptation and the fact that businesses around the world, frankly, are failing still to address the reality of global climate change and what that will mean to their businesses, and to not only more and more people focusing on mitigation, but very few people, relatively speaking, focusing on adaptation. So again, something perhaps for a future discussion, if you'll have me back. So that's my little plug. So I go around, I spend a lot of time talking to people, to groups, to customers, to government agencies around the world. And I do get the question, over the last 6 months, I've gotten the question quite a bit, does green still matter now, at this moment in time, in the worst economic environment of a generation or a couple generations? Does it still matter? And I'm here to tell you it does. It matters because we are in the worst economic environment of a generation. But at the same time, we're seeing a global awakening to the danger of climate change and to the impact of greenhouse gas emissions, and something needs to be done. So it matters because it's, as you'll see, it'll help us to save money. It will help us to prepare for the rapidly shifting compliance market, and will help us, our businesses, to compete more effectively in a society that is constrained with resources, water, energy, and where carbon is monetized. So I'd like to start by first sort of saying that when IBM talks about energy and environment, or green, we really care about three critical resources: water, energy, and carbon. And these things, as you would expect, are inextricably linked, right? It takes water. 40% of the fresh water in the United States passes at some point in time through a utility to generate power. Power requires water. Water requires power to move it and cleanse it. The use of power, of course, results in carbon emissions, etc. So we focus, as we work with clients, on all three of these areas. And again, as we talk to clients, the first and foremost, the primary reason is not because they're worried about the polar bears in Antarctica. I mean, not to mitigate that, but quite frankly, as we're working with clients around the world, the focus is on how can they remediate some very significant operational issues that they have. In the space of IT, many of our customers are just flat out of power at any price point. They can't get more power into their data centers. They can't dissipate the heat that's there. In places like India, you can't get availability to reliable power supply. And in fact, Gartner issued a report earlier this year that said that 50% of businesses that they surveyed last year had application outages due to power or thermal issues in their data centers last year. So it's a very real operational issue for many of our clients. It's an economic issue. Again, whether you're talking about energy use in IT or energy use in buildings or in manufacturing operations. So there's the opportunity to defer costs, to defer capital investments. There's the opportunity to mitigate risk, but there's also this notion of strengthening reputations and preparing to meet the rapidly emerging compliance market. And then finally, we believe it'll help our customers compete more effectively in markets. Now, as we look at this, we focus across the whole breadth of a business's operations. When we first started talking about this a couple of years ago, we were very focused on data centers and on the use of IT, and that's sort of what you would expect from a company like IBM, but What you might not expect is that our capabilities and our ability to help shape this expand across all aspects of business operations, from its supply chain to its manufacturing operations to its distribution networks to the way that its employees work. Now, it's important to look across all that range because there's some very interesting, unexpected areas of cost that you find as you look across this. And these are just a few examples, right? So the one on the left is over the life cycle of a pair of jeans, manufactured through 5 years of ownership. That's how many liters of water are consumed in that process. Another example of water is that it's been estimated that the top 5 beverage manufacturers worldwide consume enough water in their manufacturing operations to meet the daily needs of every single human being on the planet. Just think about that for a minute. In the second one, IT, data centers alone, in order to mitigate the CO2 emissions associated with the 185 billion kilowatt hours of energy consumed by data centers worldwide, you would need to plant this many trees to offset that. Now, the good news is that we're finding that in the U.S. Department of Energy has estimated that you can save 40% on average, and we're in fact seeing 42% results later in energy reduction associated with this. So there's huge potential if we just focus even on half of that. You could, it would be the equivalent of planting over 1 billion trees and letting them grow for 10 years if you're worried about climate change. Just focusing on data centers, forget distributed IT, just data centers, and do half of what the government suggests is possible and what we're actually finding is possible. And then the third area here is important because this is $46 billion spent on carbon offsets in support of the Kyoto Protocol. As the world comes together at the end of this year in Copenhagen to address climate change and the follow-on to Kyoto, as the U.S. gets serious about climate change regulation, the monetization of carbon will, and the marketplace for carbon will only grow. Now, there's also significant areas for savings opportunities. Just a couple examples. IBM, it turns out the chip fab is a very significant water user. It's the third most water-intensive industry in the world. Microchip, not potato chip. So, this is a joke here. So make sure you guys are awake. So, by analyzing our manufacturing operations and processes, we changed just one step in the chip fab process. And that one step in one manufacturing site in Burlington, Vermont, is saving us 20 million gallons of water a year. Now, at the same time, we've increased production at that site by 25%. So 20 million gallons of water saved, 25% increase in production, and $3 million a year in energy in savings, half of which are water costs and half of which are energy costs. So it shows that there is real potential. Care2 is a social networking site based out of California. For them, IT is their infrastructure. They've grown from 2 million subscribers to over 10 million subscribers, and they cater to the socially conscious community. For them, it was important not only to become more efficient, but it was important for them to demonstrate that they were being efficient and being green because that's what their customer base expected. So not only did we help them by virtualizing and consolidating their servers and more intelligent design of their data center, cut their energy costs by almost 3/4. But we also helped them apply for and earn something called energy efficiency certificates so they could document that, publish it to their customer base, and they would tell you that it's had a significant impact in attracting new users to their social networking site. And then finally, Tesco is a large grocery store retailer in the UK, and by simple analysis of their product lifecycle management, identifying ways to make the wine bottles lighter to reduce shipping costs and the CO2 emissions associated with that. Now, there's also a rapid shift in growth in regulations. I like to tell people that it's like that on your mirror where it says objects are closer than they appear. Climate change regulation and monetization of carbon is closer than it appears. There are now 59 countries or jurisdictions around the world that have either on the books or ready to go into action within the next year carbon management systems. And this isn't just about the large emitters. A lot of people think, well, carbon cap and trade systems or carbon management only applies if I'm a utility company or a cement factory. If you look at CRC, the Carbon Reduction Commitment Act in the UK, for example, it goes into effect in April of next year. It will affect over 3,000 businesses in the UK. There's less than 1,500 what we call large enterprises in the UK. So it's going to have a massive impact in every industry and companies of all sizes. And you can anticipate the same sort of regulation to emerge here. 75% of companies see an increase in the number of advocacy groups, and over 82% of CEOs surveyed suggest that they believe that they will be impacted by climate change regulation in the next 5 years. So this is on the minds of CEOs, it's on the minds of stakeholders, it's on the minds of consumers and potential investors, potential employees. And then finally, consumers are saying that they will vote for their wallet. So in a marketplace where the consumer wallet is shrinking and we're having to compete more effectively for that shrinking wallet, being sustainable and demonstrating that is important, and certainly that's what Compare2 has discovered. All these things suggest that there's a mandate for change, for making the systems that we work with fundamentally more intelligent and more sustainable. The whole notion behind IBM's Smart Planet initiative is the thought that as things become more instrumented and as they become more intelligent and connected, we have the opportunity to fundamentally change the way the world works. Not just the IT systems, but to leverage IT and technology to change the way manufacturing systems work, the distribution systems work, the way that water infrastructure works, the way that utility networks work. And that's what this is all about. Now, together, we think, but put these things together, that we can, in fact, reduce costs for businesses and for societies. We can alleviate operational barriers. We can, address climate change regulation, and we can help businesses compete more effectively. Now, there's 3 areas that, when we talk about energy and environment, there's 3 areas that we focus on. The first, and I'll touch lightly on each one of these before we go to Q&A. The first is what we call green infrastructure. That's looking at IT, but all of your physical infrastructure. Buildings, plant flow automation systems, vehicle fleets. So looking across all of your infrastructure, how can you make that infrastructure more efficient? The second is looking at your business operations, whether it be, again, your supply chain or your manufacturing operations or the way that your people work. And the third is looking at not you as a business or you as a part of an ecosystem, but looking at the macro system, looking at how utility networks work, looking at how water infrastructure in a city works, looking at oil exploration. So I'll lightly explore each of these areas. At the infrastructure level, this really has 5 specific areas, and I know it might be a little hard to read at the back, but I'll just sort of walk you through it. The first is IT equipment itself, and you might say, well, why do we focus on IT? Well, IT represents, as you've read, 2 to 3% of the energy consumed worldwide, but it's growing very rapidly. Our customers are telling us they're seeing their IT capacity double somewhere between every 9 and 36 months. It depends what industry. Digital media, certain financial markets are doubling faster. Healthcare are doubling faster. But it's large, it's fast growing, it's horribly inefficient. The average utilization of a server is still, even after the last few years of virtualization efforts, still is less than 12%. The average utilization of a storage device in the market at large is less than 25%. So there's lots of room to improve the utilization of these assets. And there still remains a significant lack of accountability. Still less than 30% of IT managers see the energy bill. And so the reason we focus on IT is it's a rich area to focus on to improve, but also because it's a fulcrum point. Because in this vision of a smarter planet, IT plays a critical role to making all the other systems more efficient. So it's important that we focus on getting this piece highly efficient first. So from an IT equipment perspective, we have the ability to make systems more efficient. Everything from the power supplies to the displays to the fans that that consume the most energy within a server. Virtualization and consolidation is the single biggest lever to help drive up the utilization of the assets, drive down the number of devices. At the data center level, just the intelligent design of the data center can have a significant impact on the amount of power consumed, because in many shops today, as much energy or more energy is consumed by the environmentals, the air conditioning systems, the chillers, than by the IT equipment. And so by more intelligent design of the data center, we can make it more efficient and have more power going to the IT equipment itself. So, and we've also been focusing on what we would call a sort of more intelligent modular approach to building out data centers, because the traditional design of a data center is you build a big room like this, you put in the chilling capacity to cool a room this size, and then you slowly populate it, or rapidly populate it, with IT equipment. The approach that we've been on is to sort of go with a more modular approach where you're adding the environmentals as you add the capacity, the server storage capacity. At the real estate and facilities level, we now have the capability of working with partners like GE, Johnson Controls, Honeywell, and others to look beyond the data center to monitor rooms like this, lighting systems, air conditioning systems, fire control systems, and optimize those systems for energy use. So again, we're very much focused beyond IT to across all the building infrastructure. Our point of view is that no matter how efficient you make the infrastructure, if your data is doubling every 9 to 18 months, and if your application compute capacity is doubling every 24 to 36 months, you don't have a sustainable equation. So something must be done to address data growth and application growth. And so we're investing a lot in helping customers stem the growth of data through data compression algorithms, data deduplication techniques. You know, the average PowerPoint presentation like this in a medium-sized business exists 39 times. So just because people keep multiple copies, they don't. So just through simple pooling of information, deduplicating, you can have a significant effect on lowering the amount of data that you have. Through more intelligent information lifecycle management, you can move it across this lifecycle and eventually delete it at the right moment in time. Using techniques like SOA, service-oriented architecture, you can design your applications and processes to be more efficient and less resource-intensive. We're delivering tool sets to help developers write code that is not only efficient, but to deliver code that is designed to run in a shared, virtualized, efficient environment, as opposed to requiring a dedicated system, which is sort of how we got into the mess that we're in right now. As a university, by the way, I play a critical role in helping to sort of shape this next generation of developers. And quite frankly, when I was a programmer, I'm so old, and I wrote microcode, and we cared about every single bit. People got sloppy over time, right? We need to return to a generation of developers who are conscious about the footprint of their applications, their processes, and their data. And then finally, energy management. We deliver the capability to help you monitor, manage, and optimize for energy use across the entire infrastructure. And again, IT managers have historically focused on availability, transaction throughput, security. We believe going forward, energy optimization is going to be a new muscle, a new discipline that must be exercised in the infrastructure. And not just IT, but looking across the whole infrastructure. Being able to allocate energy costs is also very important. I used to, if you read that, it's a little bio there, I used to have responsibility for virtualization in IBM. And I can tell you the single biggest inhibitor to people adopting this notion of virtualization was end user resistance. You could say to a user, look, I'll give you a lower price point if you move your application to a shared instead of a physical server. No. I can guarantee you higher availability if you virtualize your storage instead of having it on your dedicated disk. And they'd say no. You can say that same recalcitrant user, well, this is for our green efforts because it will reduce the energy footprint of your application, your process, your data set from this to this, and they will do it. Whether it makes any sense or not, they will make a shift in behavior for green that they won't do for other reasons. So being able to, whether you do charge back or not, being able to give visibility to the energy footprint of your environment is critically important. So all this together is the infrastructure. Now, just some examples. We've had the chance to work with over 3,000 customers in the last 24 months alone. Some of those were data center design and build, some were virtualization projects, some were storage virtualization or server consolidation, some are energy management. The average energy savings has been 42%. The average return on investment has been less than 24 months. In many cases, it's less than 18 months. So significant ROI, significant energy savings, and in a number of cases, what customers tell us is for every dollar they save on energy, they're saving $6 to $8 in operational costs. That manifests itself in real estate costs, in reduced maintenance, software licensing costs, hardware and software maintenance costs, and reduced administration and management costs. So there are significant benefits, cost benefits to doing this. We're finding that people like SunTrust have had significant reduction in their total storage footprint and data set footprint by more thoughtful compression algorithms and data duplication efforts. And then finally, we're working with a company called Star Technology Services in the UK that's looking well beyond their data center to looking at their entire building infrastructure and optimizing that for energy use. And these are just a few examples. Now, the second area that I want to mention is around this notion of sustainable solutions. And here, it's really about how do you leverage IT and this notion that things are more intelligent, connected to address improving the performance of your manufacturing operations, the performance of your supply chain, the performance of your distribution network. So it's a combination of instrumentation, doing things like RFID tagging, to deep analytics, to looking at linear programming and game theory type of things, to look at the distribution network and find ways to optimize it with an eye towards minimizing energy use, minimizing carbon emissions, and minimizing water use. We've applied the Lean Sigma and Six Sigma methodologies. We've actually created something we call Green Sigma, which we've trademarked and copyrighted, and we now are applying that methodology in our customer base to help them optimize their operations for these critical resources. It's also, though, about looking at how your people work. An example of this is within the IBM Corporation, more than 40% of our workers don't come into an IBM office every day. And that doesn't count the sellers who are just on the golf course. This is people who have mobile workers who work from home or work from a customer location. And in fact, if every IBMer showed up at the office tomorrow, we'd have less than half the space necessary worldwide to house them all. Now, what that means is that they're not getting in the car, commuting, and emitting, spending time in greenhouse gases, getting from home to work. It also means that it's having significant savings for us because our real estate footprint is much smaller. We've got the reduced energy and carbon footprint associated with that, but of course the reduced cost footprint. That's been a big part of our total end-to-end energy savings across the IBM company over the past number of years. So it's about enabling remote working, providing technologies, whether it be video conferencing or collaboration tools like Same Time and that sort of thing, enabling people to dematerialize their activities as opposed to appearing in person. Now there's just three examples here. The first is that Costco it's not Costco like you shop here in the US, it's Costco in China is a large shipping and distribution magnet. They went from 100 distribution centers down to 40. Again, just by thoughtfully analyzing their distribution network and changing the routing patterns, we were able to, as you can see, perhaps they reduce their carbon emissions by 15%, their fuel costs by 25%, and they had no impact in terms of their service level agreements with their end users. So a significant improvement. I mentioned the Burlington Fab example already. Again, the important thing there is that while water is frankly undervalued in terms of, so saving a gallon of water has relatively small cost benefit to it just because we undervalue water in terms of the pricing model around the world today. But the energy savings, the waste treatment, and the chemical savings associated with that add up to a significant amount of savings. And we're now, again, applying these sorts of methodologies with other IT companies, with bottlers, with beverage manufacturers, with paper manufacturers, et cetera, around the world. And then finally, from a real estate perspective, again, what we're finding is that customers, in some cases, are cutting their real estate costs by as much as 80% by moving to a more mobile workforce and this notion of dematerialization. The third area that I'd like to talk to you before we close or to take questions is this idea of looking beyond your business or supply chain to the macro system, thinking about intelligent utility networks or transportation systems. So let me just give you a few examples. In the area of water, in the previous section is where we would be working with a company around the notion of industrial use of water and how they may modify their processes and their operations to reduce their water consumption. In this example, we're working with cities and with government agencies around water infrastructure. So as much as 50% in some cities, as much as 50% of the water is lost in the distribution of water through leakage or through illegal tapping into the water supply. And so we're working with cities to instrument the water system, to identify leaks, to identify contaminants, to be able to fix those more quickly and aggressively, and also to look for unauthorized use. In the island country of Malta, we're actually implementing not only a smart electricity grid, but a smart water infrastructure and smart meters in the homes of every citizen of this island nation so that they can monitor their water use as well as their energy use and change their behavior accordingly. We're also working with cities and countries around instrumenting dams and levees and dikes to identify, and do predictive analysis of when a levee might fail. In cities like Chicago, working at water, looking at the confluence of, they have a significant issue like many cities do where when you have significant amount of rainfall, it overflows the gutter system, and if you have that simultaneously with a spike in sewage emissions, then bad things happen, right? It backs up into Lake Michigan, backs up into the streets, not a good thing. So we're, in that instance, what we're doing is focusing on the potential of smart meters to allow better control over sewage emissions and micro weather forecasting, something we call Blue Thunder, to be able to do very accurate weather predictions down to a multi-block area as far as how much rainfall will occur, and then be able to determine where, if you're going to have a sudden rainstorm here in this section of the city, how can you reduce sewage, water demand and sewage flow in that section so that the two systems don't spike simultaneously. So there's that sort of thing. And then finally in the water area, we just recently announced a project that I was talking about at dinner last night in the Bay of Galway in Ireland. We're working with partners instrumenting the bay with sensors to do everything from monitor fish populations to algae blooms to doing predictive analysis on wave generators, because they're, and the real challenge there is we don't do the instrumentation, we do all the data analysis, data crunching, and the presentation of the information, because in this context, you're trying to provide all this information to a set of users that range from the harbor master to the fishing industry, to the tourist industry, to the utility industry, to the security services, to be able to look to see, and provide the right information to the right users. So it's a very complex task, and something that that would be certainly applicable in other areas like your own. Right? In the area of traffic, we've had the chance to work with a number of cities around traffic congestion systems, and this is not sort of the first generation of these technologies was, sort of put a, like London did, put a congested charging zone, and you charge if you go into that zone. This is a lot more sophisticated in the sense that the work that we've done in Stockholm and in Singapore is to be able to change the price, the congestion charging, almost on a minute or sort of hour by hour or 15 minute by 15 minute basis based on congestion and air quality at that point in time in the city. In fact, in Singapore, what they want to do is not only be able to react to congestion and change the congestion pricing, but they want to predict it up to an hour in advance, predict where a congestion will occur, and be able to influence driver behavior to direct traffic away from that zone to a different zone. And so they have the instrumentation, and now we're helping with the analysis to be able to do that predictive modeling and constantly moving the bubble around to try and deal with the traffic issues. Smart energy is looking at things like smart grid, to put more intelligence into the utility network, because as you've probably heard, as much as, from the power being generated at the plant to the point where it's consumed at the wall, as much as 60% of the power is lost through transforms and other inefficiencies in the grid. The notion of a smart grid is to make the grid far more intelligent so they can protect itself in a more intelligent fashion, because the grid is very old and antiquated, and its prime directive is protect itself at any cost. When it senses a surge or a fault, the challenge is to isolate that fault so it doesn't cascade and result in the sort of blackout that we had here in the Northeast a number of years ago. So one thing a smart grid will do is put more intelligence into the grid to allow it to be more efficient, but also to allow it to protect itself more effectively. The second thing is by putting smart meters in homes, we can change the behavior, the consumption behavior of end users. The third thing is that we need to be a smart grid to be able to support distributed generation, solar and wind, and distributed storage, like plug-in electric vehicles. So we're doing a lot of work around smart energy, not on the chart, but just out of interest perhaps. We're also using our material science capabilities to look at micro problems within the energy space. So working on our expertise in cooling technologies to make concentrated photovoltaic more efficient, to solve the cooling problem that you have with concentrated with CPV. We're using our experience in membranes to make water filtration as much as 40 to 50% more energy efficient. So 40 to 50% less energy to desalinate water, to make membranes that will more effectively take contaminants out of water and natural minerals out of water, like arsenic, which is predominant in wells in places like Africa. And so we're using our material science expertise in areas that you might not expect to apply to these sorts of energy and water issues. Now, just some examples here. I mentioned Stockholm. The interesting thing to me about Stockholm is that they didn't want to do a pilot. They didn't want to do a small pilot. They went full bore with a full project, but on a limited time basis. And then they put it up to a vote for the citizenry. The citizens voted to make it a permanent action, and you can see, if you can read it, you can see some of the impacts. Basically, they cut traffic by 20%, emissions by 12%, and they had 40,000 incremental riders shift on a permanent basis to public transportation. So it wasn't a one-time surge, it was a permanent shift. So they've had a significant impact there. Dong Energy is an example of a smart grid project in Europe that we've done. And in Malta, as I mentioned earlier, we're instrumenting the entire island nation with a smart grid and smart water infrastructure, and presenting again the consumer with smart meters to allow them to monitor their energy and water use, and the dashboard at the country level to be able to manage this as literally a smart country. Now, just to let you know, we have a lot of different capabilities in each of these areas. This is not meant to be an IBM advertisement, but just because a lot of people say, why is IBM? I thought IBM was a mainframe company, or I thought IBM made ThinkPads, but we don't do that anymore, by the way, ThinkPads. But we do a lot of capabilities here, and really what we bring to the table are three things. One, we are today the world's largest R&D organization. We spend about $6 billion a year in R&D, and a substantial portion of that goes into these technologies and spaces. Two, we are a technology innovator. and IT is our forte. But we also have deep industry insights. So we understand how utility systems work. We understand how retailers work, how financial systems work. And so we're applying that industry knowledge to help modify the processes that there. And then the third reason is, this is more, addressing this area of green or energy environment is as much a process and a behavioral change as it is a technology challenge. Whether you're talking about monitoring for energy use in the data center and optimizing for that, or you're talking about to a utility network, which has traditionally been a sort of a hub and spoke model, a one-way conversation between the utility company and the consumer, to now where it's much more of an internet-like web of connectivity, distributed power generation, distributed power storage, sending pricing signals to consumers who then respond to that, two-way communication between the consumer and the power company. Those sorts of process re-engineering capabilities are a forte for us, and another reason that we are experiencing this. And then the final thing I would say is we have a lot of experience in this, in that we put our first sustainability agenda in place in 1972. We've been reporting externally on carbon emissions since 1990. And since 1990, we have reduced our carbon emissions across the company by 45% relative to, by year-end 2007 relative to 1990. And that was net of any divestitures or investments, so across everything. And in that time period, just to give you a sense of it, we've saved enough energy in the previous 16 years to pay the entire IBM power bill worldwide this year, which is pretty phenomenal. It's a lot of money. So we do have some experience here that we could partner with you all on. So let me just close there, and I think we have like 10 minutes left for Q&A. Again, the focus here is, yes, it's about saving money. Yes, it's about deferring costs. It's about remediating operational issues, but it's also about preparing for a society where energy and water will be more constrained, where carbon will be monetized and valued, and where people, stakeholders, investors, employees, consumers, will make decisions based on how sustainable business is. So let me stop there and see if I've provoked any thoughts or comments. No? Yes?
Thanks, Rich. That was fantastic. I have one question about a lot of your projects, especially I think the most innovative ones, are overseas. And I'm wondering if we're falling behind in implementing some of these smarter choices for infrastructure and energy, or if we'll have the advantage of following on after the experimenters figure out all the bugs. So I was just wondering if, your opinion on that as far as the U.S. policies.
So I think that, first of all, we have done a number of these projects in the U.S. as well. I mean, with PNNL, Pacific Northwest National Labs, was the first smart meter project that we did. We have a very large smart meter project going on in Texas, and we have about 17 going on right now around the world in implementation, many of them here in the U.S. So I didn't want to give you the sense that we're not doing it. At the same time, I will tell you that places like Ireland and Singapore have set the goals for themselves to be centers of excellence for the green economy. They want to be, Singapore aspires to be a center of excellence for all of Asia for smart cities, smart buildings, and smart water infrastructure. It's publicly stated goals. Ireland aspires to be a center of excellence for water, as does Copenhagen in Denmark. So there are places elsewhere in the world which have sort of set the stake out and said, we are going to lead the world in this next economy. I think that with the Obama administration, certainly he aspires to that, and I think we have some catching up to do. I think we have the opportunity. The stimulus package certainly is helping to stimulate interest in smart grid projects here, and smart building projects and efficiency projects. We're involved in a number of those. I think water infrastructure is an area that, frankly, we're not focusing on enough here in the U.S. or in many parts around the world. So we have more work to do there.
You talk about the impact all the way down to the smaller business and consumer, whereas desktop servers, most of the manufacturers now have these energy saving options. I'm not exactly sure what they're doing it, but there are options for the power supply and things like that, but they're costing $10 to $25 more. And I know among my clients, when we do larger orders of PCs, 50, 100 at a time, they look at that $25 and they say, no, we're just going with the standard. So what do you think it's going to take to make it change, not so much in the financial, from the manufacturing process, to the pricing that you come?
I think so the question was, you know, there's still a premium for some of this technology at the consumer level for more efficient software or hardware. I think there are some premiums, but overall, generation on generation, every manufacturer, IBM or Dell or HP, we're all making our systems more efficient. And in most cases, we're not charging premiums for that. But the challenge we face, acknowledge, is that whether you're talking at the end, less with the consumer than in commercial space, this classic OpEx versus CapEx, right? So the person making the buying decision is focused on the capital cost and not the long-term operating costs associated with this. That's true for energy as well as other aspects of it. So that's a challenge. Again, for our purposes, as we work with clients, oftentimes we have to talk to the CFO to have the conversation that says, look, because the CFO does care, the CFO does see the energy bills. But you're right, it's a challenge on some of these things. Now, if you can demonstrate an ROI of 12 months or less, in many cases we can, then you can overcome that. Yes.
Talk a little bit about telecommuting.
So the question was, can I talk a little bit about telecommuting? So the enablers for it are, first, wideband, decent, some sort of collaboration tools, whether it be online conferencing or we've found that instant messaging can be a very effective tool to enable people to work when they're not in physical proximity to each other. And it's sort of, maybe that's counterintuitive, but the informality of a same-time message or an instant message is such that it promotes collaboration much more than having to pick up the phone where somebody's already on a call or sending them an email or something. So that's I would say if there was one tool to better enable distributed workers, or enable, I would say an instant messaging tool would be the first thing I propose and the cheapest thing. Video conferencing is still, things like Cisco's telepresence, fantastic technology, but it's $400,000 to implement. I mean, it's horribly expensive. Now, that technology, the price will improve, and with competition and as the technology advances, and it is fantastic. You feel like you're in the room if you've not used it before. But it's it's point to point, and it's grossly expensive. But that's an important technology, and certainly the industry is moving to the point where we'll have that in our homes within the next 5 years or 6 years, I predict. So the cost point will come down, and you'll be able to do it that way. The other important thing about telecommuting, we think, is you have to be able to provide an office space on demand for the employee, because you can't completely disconnect them. So while we have less real estate now, we have a very good hoteling scheme to allow people to come into centers of IBM centers to use capacity. One of the things we're finding, by the way, in smart buildings is not just about making them more efficient in terms of lighting systems and all, but also populating them more efficiently. So we're now working with a number of building owners and operators where they're talking about instead of allowing people to sort of populate the little cubicles wherever they want, they assign them as they come in, and you fill up the building in a logical way so that you're not cooling and lighting the entire building at 6 a.m. Or at 9 p.m., but you're doing it in a logical way. So I don't know if that answers your question. Other questions? Yes.
I was involved in solar energy in the 80s, and that came and went. What's going to stop this from being, just this moment in time, like some of these other initiatives were?
So I think the difference between now and say, the 70s, right, is while energy prices spiked and came back down again, the volatility of energy prices and the fact that there is this sort of continuous climb upward is one thing. The fact that there's now a serious worldwide effort to monetize carbon and the energy use that's associated with that, I think will make this a sustained thing. The fact that the technology, solar came and went because it was heavily subsidized, and as soon as the crisis went away, the government subsidies went away. I think it's now much more commercially viable than it was back then. It's still, I don't think many solar implementations couldn't stand an ROI on their own still today, but the number that can, with it standing on their own without some sort of a subsidy from a utility company but the number that can is growing dramatically, and all the experts would tell you that within the next 3 years, solar will be commercially viable, independent of some sort of utility subsidy in terms of price per kilowatt hour. And the ability to, finally, the notion of a smart grid, the ability to support this distributed generation, and being able to, as in California, where it's mandated that they have to take the excess power back into the grid, is, I think, also going to change the dynamics dramatically. Other questions? Yes?
I had a follow-up question to the teleworking question. What are your thoughts on where does the virtual environments, the virtual world kind of fit in terms of as a collaboration tool? You mentioned video teleconferencing and at the same time.
That's a great question. I mean, again, it shows my age, right? The social networking tools like Twitter and virtual reality worlds are going to become far more important, particularly as your generation comes into the workforce. Twittering is now a way of life for many commercial institutions. Virtual reality worlds are, we have IBM has a presence on Second Life, and an island there. We actually have a virtual green data center. So you can go to our virtual island, and it's staffed by avatars 24 hours a day, 5 days a week, multilingual avatars. So Japanese, Chinese, Spanish, French. And you can get a tour of a green data center. Now, you may have some guy flying in naked or something at some point. I mean, that's sort of, but where we're at is where we were at in the early, very, very early days of the internet. Remember the HTTP : // that's where we're at in virtual reality worlds in terms of maturity and ease of use. That will fundamentally change here, and it will change dramatically. And we will see people having events like this in a virtual room, in a virtual reality world, in the not too distant future. But it will be your generation that brings it into the workforce and demands it, as opposed to sadly mine. So. But that is a very important issue. By the way, I was on a panel in December of '07 with with this company, the outsourcer that runs Second Life for Linden Labs. And he confirmed the fact that at that point in time, that an avatar in Second Life had a larger carbon footprint than a real person in Brazil. That's just how inefficient the IT infrastructure is, right, or was. Now, they've come a long way since then, but it just goes to show how much room we have for improvement in IT. So look, I'm getting the hook. Thank you very much for your time.